Hi, good morning. I'm Professor Pena from São Paulo, Brazil. I want to show my paper related to some recent experience obtained with DMT tests in São Paulo soils, in Brazilian soils. We have some examples since from residual areas, also in very soft sedimentary clay near the ocean, and also in a hydromechanical field of reject of mineration, and in a compacted, very hard compacted silty soils near São Paulo. That's what is summarized in our paper. Thank you.
Hi, my name is Bill Corey. I'm with Schnabel Engineering. This project is for a prison that was done in King George County in Virginia. The project consisted of about 5 to 10 buildings, 1 to 2 story levels. We did about 15 to 20 borings on the site, and we found out that the material is mainly consists of granular sandy soils and very loose. To investigate this soil a little bit better, in addition to using SPT values, we went out ahead and we did dilatometer, we did cone penetrometer, and we also did pressure meter tests just to compare the results and try to predict which method will give us the best results. The analysis was done by Mr. Sadat from the University of Texas, and he should be able to talk to you a little bit more about the results. Thank you.
Okay. And again, start off with your name and then tell us a little bit about the results.
Yeah, I'm Sadat Hussain from University of Texas, Arlington. The result we are presenting here is a comparative study of different in-situ tests for site investigation. And this work I did when I was working with Schnabel Engineering before going to University of Texas at Arlington. Schnabel, it's a good company, and I think they're doing a lot of good work around Gaithersburg and Greater Washington DC area. So as Bill said, the project was basically for a prison building, and they did more than, if you look at here, they have more than 25 test boring. Now, based on the test boring, the settlement number they got was unusually high. So they wanted to go get a better feeling of the site and came up with the testing using the cone penetration test. They also use pressure meter test, dilatometer test, and to confirm all the number, we did the plate load test. Now, once we have all the data, what we did a comparative study of the bearing capacity using the SPT, CPT, DMT, and pressure meter test. And it showed consistently that SPT gives a lower bearing pressure, which most of the time you use for the design. And on the other side, using this SPT data, we found the settlement numbers are way too high. Using the same data, we found that DMT and pressure meter test gives comparatively higher bearing capacity. And this higher capacity translates into lower settlement. Now, how do we know that which settlement is better? Which settlement is giving us a good prediction? We did the plate load test. And for 2000 PSI bearing capacity, we found the settlement was around 0.2 inches. The point to note here that the plate load test was done one of the worst location for the footing. So that means it's expected the settlement will be higher than the other location. Now, if we go with the same logic, the pressure load test for 2000 bearing pressure capacity gives us a settlement of 0.2 inches, but DMT and pressure meter is giving around 1 inch of settlement. We feel pressure meter and DMT results are better than others because plate load test is expected to give higher settlement than the actual, and the actual test result or settlement result is basically coming from DMT and pressure meter test. So this is a very comprehensive study showing that pressure meter and dilatometer test gives better prediction for the settlement and bearing capacity. Thank you.
Hi, I'm Brian Anderson. I helped Roger with the proceedings for this conference. I'm glad I got to take part. The subject of my poster is something that's very near and dear to my heart. I've spent the better part of about 10 years studying the prediction of lateral load tests based on dilatometer input data. We're actually really prediction of lateral load tests in general, and the dilatometer is just one tool that I've used in those predictions. And this was a good opportunity to put together a case history paper. The reason I wanted to put this one together is in the 10 years I've studied this problem, gathering data seems to be the hardest part. Pulling together data from many different sources, folks who perform the load test, folks who perform the initial soil testing, and trying to mate that together to do a real analysis has been tough. So what I did is I took 6 cases that I've studied in the past and pulled all the data together. If you look in the proceedings paper, you're going to have all the information from the initial dilatometer data to the structural data for each pile or drilled shaft studied, and the PY curves we derived, as well as the load test results. So the person who actually reads the paper will have the opportunity to do their own analysis. And I think that's got a lot of value, because I mean, we're at one point with the technology, and it's only going to improve as people develop better methods. So that's really one of my goals in providing this paper to the conference. But what it really does show, if you look down on the left side of the plots, the actual load transfer curves for each of the load tests that you see on the left. And you can see that there's Roosevelt Bridge from Florida, US 17 bypass, Ryman, North Carolina, Puerto Nuevo, Puerto Rico, Salt Lake City, Utah, Pascagoula River Bridge in Mississippi, and Auburn, Alabama, at a load test site in Auburn, Alabama. So we have a pretty good cross-section of the South, and then with the addition of the Salt Lake City. And we took the dilatometer data from each one of those tests as provided in the proceedings paper, derived PY curves for each location, and then we plugged them into a piece of software that I worked with at the University of Florida called FB Multi-Peer. It's pretty much the state of the art for lateral loaded pile analysis. We used those derived PY curves and predicted what the pile top deflection was. We could have presented a lot more information of the entire pile length deflection, but there just wasn't room in the paper to show it. But looking at the pile top deflection versus load results, we have a pretty good correlation using the dilatometer load transfer curves, and that gives me a pretty good, some confidence if I'm using that in a pile design. It is a notoriously difficult problem to solve. If you looked at the equation, it's really like a differential equation that you're having to solve, and we're doing a simple engineering solution to a differential equation, and the dilatometer gives us a pretty good input. So that's pretty much all I got. I appreciate it, and thanks for having me at the conference.
Okay, my name is Dave Knott. I'm with HDR Engineering, and this is a project where we had started out using conventional soil sampling with standard penetration test and Shelby tubes, and it turns out that the soils were incredibly soft with weight of hammer and 0 pocket penetrometer readings, even with the foot attachment. So we had to go to dilatometer and borehole shear testing to get some of the soil strengths. And this site turned out to have been an old slurry pond for the washing of sand and gravel. And this is an example of what the soils look like under much of the site. And our strengths in these very soft soils were maybe 200 pounds per square foot up to 1,000, where fill had been placed on top of them in the past. And we were able to use the dilatometer and the borehole shear to get strength parameters so that we could do a design for a confined dike disposal facility to be built on top of this existing site.
Hi, my name is Junyi Chen. I work with CH2M Hill. Today I'm going to present the project that we did in Richmond, Virginia. This project is for Virginia Highway Route 288 around the western suburb of Richmond, Virginia. We have a cut slope. The original study recommended the cut slope as flat as 5H to 1V, 5 horizontal to 1 vertical, with a drainage blanket. The reason behind this recommendation originally was because there are a history of slope failure in this area. And we kind of understand this now because just a few miles north of our project location, we're dealing with numerous slope failure in this area. And the cost for the fix-up is around $750,000 for the slope failure. But anyhow, this cut slope project was originally recommended as 5H1V as a slope ratio. Now we perform 4 dilatometer testing and 3 piezo-cone penetrometer testing to reevaluate the strength of the soil and the deformability of the soil. First on, we perform finite element and slope stability analysis to reevaluate the stability of this cut slope. The cut slope was found to be stable at a slope ratio of 3 horizontal to 1 vertical without a drainage blanket. So I guess the slope right now still stands as shown in this figure or this photograph, and the highway is up and running, no obvious distress on the slope. That's a 2 minutes presentation of this project. Thank you.
Hi, my name is Jess Gorski, and I'm with Rummel, Klepper & Call in Baltimore, Maryland. And my paper is based on a project that we did up in northern Delaware, and it involves the relocation of interchange ramps where SR1, SR7, and I-95 meet. Now, this area here is in the Potomac Formation, which consists of over-consolidated silts and clays with sand and gravel lenses. Our field testing program involved several SPTs, CPTs, DMTs, Knott blades, as well as Shelby tubes. And basically, we compared the results that we got from all of the different tests. And it turns out that the DMT data and the Knott blade data did converge above a depth of approximately 15 feet. We'd assumed that it was just over-consolidated and the soil had all been kind of broken apart and stuff. The water levels had changed over time. We just assumed it was desiccated. Beneath that depth, it did converge to about 1. The CPTs also and DMTs we compared, and they were very similar for their stress values. They converged like we had assumed. Our conclusions based on this are that it's very good to use the In-Situ test as well as your SPT test and whatnot to get your soil parameters. They kind of work together. When you do your laboratory testing for your Shelby tubes and your SPT data, you get certain values which you can then use in your CPTs and your DMTs to better quantify your results, and in the end it gives you better results for your project.
Okay, and the topic of this poster is observations from in-situ testing within calcareous material. Locally, it's known as the Cooper marl material. Actually, this work has been summarized by my colleagues and myself, and we just have been working in this low country area of Charleston region in South Carolina for years, and we summarized the findings with the Cooper marl material. We found that this is a typical carbonate material, but with significantly different soil behavior with some typical problem material reported in some other areas. As you can see, the project's sites we summarized just very close to the Charleston Peninsula. This is the project site we want to show with some of the testing pilot results. And also, if you just have been to there, you can see this is the area where the new Cooper River Bridge was constructed. It was opened in the last year. In Charleston, actually, the Cooper marl material is a very uniform, homogeneous geological layer. It has an average thickness of probably 90 to 200 feet, extending from the coastal area to the inland. But it has been very beneficial to the local geotechnical practice and used to support a lot of development from DOT projects to even some residential development. We characterize this material with CPT and DMT findings based on our test in the project site. And the interesting part of comparing this finding was we used a test pile with some instruments installed as the Austenberg cell test. And this is a totally instrumented pile. At the bottom, there's a loading cell that is called the Austenberg cell. With this test, we were able to separate the findings from the bottom and also the drilled shaft. So that way, whenever there's one side of the failure along the shaft or at the bottom of the shaft, we will be able to use this capacity to back analyze the side friction or just the CFE values to compare and sort of to calibrate which findings from the CPT or the DMT will be a better way to do the testing. And very briefly, actually from the testing, we found it appears like the DMT constrained modulus and also the horizontal stress index appears to give a better correlation for the side friction by using the unjoined shear strengths. And that's our conclusion. Yeah, that's it. Thank you.
Hello, my name is Keanu Chautami. I'm from University of Oklahoma. I'm presenting work that has actually been done by a student of Dr. Zaman, my colleague. And his name, graduate student, is Haiming Lim. The project involves use of DMT to make a comparison between measurements of in situ properties compared to other properties from SPT and CPT, which are more conventional. The project involves a highway improvement, realignment of a highway project. There was an old embankment, there's a new embankment, and there were some technical challenges related to flooding. There was a flood zone area, and there was some excessive deformation that was being measured. What they did was they had 6 boreholes. The project site is geographically sort of northeast of Oklahoma City, halfway between Oklahoma City and Tulsa, close to a city south of Stroud. The testing that were done included DMT test results. The correlations were made between DMT results and typical soil parameters, including stiffness properties, including also friction angle values and measuring soil unit weight. And also comparisons were made with coefficients of compressibility and permeability. So in effect, what we found out is DMT, as was expected, is more capable of finding stiffness and settlement properties. We found some discrepancies between the soil friction angle value measured from laboratory test results and DMT. But in terms of the type of soil and settlement properties, DMT measured or fared quite well compared to the results we got from CPT and SPT and laboratory test results. Pretty much that's about it. That means we did a comparison analysis between DMT results and more conventional results, and it's more recommended for finding settlement and the type of soil. Thank you very much. For further information, you can contact me or Mr. Hyman Lim at the Burgess Engineering. Okay. Thank you.
My name is Nunu Cruz, and my work, I've been working with a lot of different soils, but this particular project is about the experience we collect in Portugal and Spain for the last 10 years, using, of course, the dilatometer tests and compared with other in-situ tests and laboratory tests. So we go over practically all the data that you can get from the dilatometer, since unit weight, the pore pressures, strength parameters, and stiffness parameters. So it's our experience in basically last 10 years.
My name is Dick Wells. I'm with a firm called Trigon Engineering Consultants out of Greensboro, North Carolina. The project that we have presented here today has to do with a new connector taxiway between two runways at the Piedmont Triad International Airport in Greensboro, North Carolina. The purpose of the taxiway is to allow construction of a new runway for the Federal Express new Mid-Atlantic hub that comes online in June of 2009. Part of the problems that we had on this particular site was the elevations are pretty well fixed for the taxiway grades, and they had to cross a very soft wetland alluvial deposit about 25 feet in thickness. And we were worried about slope stability problems with 60 foot of embankment and the load associated with it going across the existing swamp area. We had done about 33 soil test borings to evaluate the subsurface conditions and found that the materials were highly variable and very soft in nature, with a lot of the standard penetration resistances being equal to the weight of rod or less. So we brought in the dilatometer crews to run dilatometer tests, mainly to come up with some ideas of the shear strength values that we could use for our slope stability analysis for designing the embankments. And we found a very low undrained shear strength values in highly variable soils, even more so than the soil test borings had indicated. So we used that data to correlate it with the standard penetration resistances to do the slope stability analysis. Our results indicate it's just now ready to go to construction, and we're going to do some detailed instrumentation programs to monitor pore pressures, deformations, and settlements to control the construction phase using staged construction to allow the shear strengths to increase by the weight. So hopefully it'll be a successful project, and we'll be able to put the 60-foot embankments without any slope stability problems on the project.
Hi, I'm Rob Nyber with WDP and Associates. I worked with Roger Falmetzger here, one of the organizers of the conference, on a project in Rockville. It was for a 6-story parking garage, the White Flint Metro Station. We reevaluated a preliminary soils report that had some N values and SPT test borings that were done that showed some loose to medium dense residual soils, silts and fine sands of generally low plasticity, transitioning into weathered bedrock of the Sykesville Formation. We performed 6 dilatometer soundings, and the results of the data are presented here in figures 1, 2, and 3. And as we found out, the soils were in pretty good condition, and our data allowed us to, in essence, double the allowable bearing capacities that were presented in the preliminary report that were on the order of 3 to 4 KSF, and we were able to put the parking garage on 8 KSF spread footings, and one corner was on 6 KSF due to some slightly weaker soils. The criteria for WMATA was set at 1-inch total settlement and a 1/2-inch differential. We also analyzed higher bearing capacities with great probability and reliability data to push the settlement criteria up to 1.5 inches and give them even higher corresponding bearing capacities. WMATA was impressed with our efforts, yet wasn't in a position to change their criteria. So they went with 1-inch total, 1/2-inch differential, and the project was successfully put together on spread footings. Thank you.
Hey, my name is Samban Detti with Thomas L. Brown Associates. This project was for determining the dilatometer modulars for backfill material and in situ soils. This graph here indicates the dilatometer modulars obtained for the backfill material, and this curve here indicates the modulars obtained for the natural soils. The backfill and the natural soils were the same. However, we saw such a big jump, 4 times as much in terms of the dilatometer for the natural soils. And we suspect this could be because of aging, stress history of the soil, or cementation of the soil. And this indicates that the nuclear gauge testing for compaction may not necessarily give you a good indicator of stiffness of the material, and therefore use of the dilatometer is recommended for stiffness of the material. Thank you.
My name is Tolol Gozer. I'm here to present DMT correlations for consolidation properties of Lake Bonneville clay. We got the whole profile of Lake Bonneville basically consisting of upper and lower Bonneville clay. This is a paper about correlation of high quality CRS consolidation laboratory test results with all those sigma p prime OCR and then constraint modulus values from the laboratory testing from CRS test, and then comparison between Marchetti's 1980 pre-consolidation OCR and then constraint modulus and consolidation properties of soil from DMT testing. Basically, the whole paper is about presenting the CRS consolidation data and then how those data compare with DMT test results.
Hello, my name is Antonio Pena. I come from Brazil, from São Paulo, and my paper is related with 4 buildings, 4 tall buildings built in São Paulo, which has spread footings, shallow foundations, and the design was based on the DMT results. We have the results of DMT, also SPT results, and also cone penetration results. All of the buildings have isolated footings, near one of the other, but isolated footings. For this building that has already concluded, we had predicted 24 millimeters of settlement, and we have measured we have measured 31 millimeters of settlements. And in this building, Morumbi building, until today, we have about 50% of the load applied. And here we have a deformation, a dish of the deformation with settlements about 1 for 2,000. And the prediction, the limit is 1 for 500. I suppose that that's all I have to say.